Hello and welcome to the next edition of the Briefings Direct podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on best practices for deploying artificial intelligence with a focus on sustainability and strategic business benefits. As AI rises as an imperative impacting companies at nearly all levels, proper concern for efficiency around energy use and resources management has emerged as a key ingredient of success or failure. It's becoming increasingly evident that AI deployments will demand vast resources, energy, water, skills, and upgraded or wholly new data center and electrical grid infrastructures. Stay with us now as we examine how rapidly developing the means to factor the full and long-term benefits accurately weighed against the actual costs is essential to assuring the desired business outcomes from AI implementations. Only by calculating the true and total expected costs in the fullest sense can businesses predict the proper fit-for-purpose use of deployments for large AI systems. Here to share the latest findings and best planning practices for sustainable AI is John Fry, Director and Chief Technologist of Sustainable Transformation at Hewlett-Packard Enterprise. Welcome, John.
Well, thank you. It's great to be here with you.
It's good to have you back. John, AI capabilities have moved outside the traditional boundaries of technology, data science, and analytics. AI has become a rapidly growing imperative for business leaders, and it's impacting the daily life of more and more workers. Generative AI, specifically large language models, are now widely sought for broad and varied uses. So while energy efficiency has long been sought for general IT and, of course, including high-performance computing, AI appears to up the game on the need to factor and manage the required resources. John, how much of a sea change is the impact of AI on all that's needed to support these complex systems?
Well, it certainly is an additional load on resources. AI training, for example, is very power intensive. AI inferencing can be the same and obviously is used again and again and again if users use that tool over and over. And those tools are designed to be in use for a long period of time as well. So I think it remains to be seen how much and how quickly, but there's a lot of research out there that suggests that AI use is going to rapidly grow in terms of overall technology use.
And, we're not honing in on how powerful and useful AI is. Everyone seems to be quite confident that there's going to be really important use cases and very powerful benefits. But I think we really need to focus, too, on what it takes to get there. And I think some people may have skipped over that part.
Yeah, absolutely. Yeah, I think that's right. And I think a lot of businesses are still trying to figure out what are going to be the best uses of AI types of solutions within their infrastructure to either add business value, speed up their processes, or save some money.
And this explosive growth it isn't replacing a traditional IT. We still need to have the data centers that we're running now performing what they're performing. So this is not a rip and replace by any stretch. This is an added on and perhaps even a different type of infrastructure requirement given the high energy power and heat requirements.
Absolutely. And in fact, we constantly have customers coming to us asking both, how does this supplement the existing technology workloads that they're already running? And what do they need to change in terms of the infrastructure to run these workloads in the future?
And we're looking at different countries approaching this in different ways. We have not a clean room approach to deploying AI. We have it going into existing infrastructure that serves cities and countries and localities. And so how important is it to consider the impact, not just from an AI requirements, but from a societal or country by country requirement?
Yeah, that's a great question. We're already seeing some evidence of jurisdictions looking at this increasing, particularly power demand, but also to some extent water demand as well, and either slowing down the implementation or even pausing the implementation for a period of time so that they can truly understand on the utilities that they control the implications that these new AI workloads are going to have on their infrastructure.
And of course, these same countries and these same regulatory agencies and groups are examining how sustainable our overall economy is, given the amount of carbon at record-breaking levels still being delivered into the atmosphere.
Absolutely. And that has been a constant focus, but certainly technologies like AI bring that front and center for them as well, both from a power and water perspective, but also from a bias and social good perspective as well. If you think the broadest use of the term sustainability, that's what those jurisdictions are looking at. And so we're going to see both some new permitting processes, I predict. We're also going to see some regulatory action. So absolutely. And that is much still in flight.
Sure. Of course, there's been some creep over the years as to what AI entails and includes. Traditional analytics and data crunching, machine learning are still there. But with these newer large language models and the inference and so forth, we're looking at also a tremendous amount of data, and the requirements for the data is another important element of the resources. How important is it for organizations to consider that initial data gathering, processing, and storing in addition to the AI modeling aspects?
Yeah, it's vital. And in fact, when we think about how HPE looks at sustainable IT broadly, and this is equally applicable to AI, data efficiency is actually the first place that we suggest that the users think about. And from an AI perspective, it's both how do you minimize the training set of data that you're using to train the model. So a great example is if you're using some off-the-shelf data sets that exist out there, like crawls of the entire internet around the globe, if your solution's only going to operate in English, you can instantly discard the types of data that have been collected that aren't in the English language. And if you're building, for example, a large language model, you don't need the HTML and other programming code that crawler probably grabbed as well. So getting the data pool right in the first place before you do the training is a key part of AI. And then you can use your customer specific data as you need to tune that model as well. So by starting with the data efficiency and getting that data population as concise as it can be from the first stage of the process, you're driving efficiency all the way through.
Sure, that's that being wise with your data seems to be a really important first step for any AI activity. Okay, we're not just extrapolating from unknown unknowns here. We have some initial understanding of what it takes to do models, in particularly around large language sets. Do you have any data points or understanding of what it's taken to get some of the existing models up and running, and how we can use that to then perhaps extrapolate or forecast what will be needed going forward?
Absolutely. So some of the early models, the data for training and inference was reported. But if we move to the latest large language model that many people are using or familiar with, GPT-4, there's been some researchers that looked at the reported infrastructure stack that was needed to train that. And they projected over 50 gigawatt hours of energy were consumed during the training process. And that training process, by the way, was believed to be somewhere on the order of about 95 days. Now, to put that level of power in perspective, that's about the power that 2,700 U.S. homes consume for a year using the U.S. EPA's equivalency model. So tremendous amount of energy that goes into that training process. And remember, that's only in the first 95 days of training that model. And then that model is used, could be for multiple years with people running inference problems against that. In the same way, as we look at water consumption, there often is millions of gallons of water used in the cooling during the training run. But the same group of researchers has predicted that the running a single 5 to 20 variable problem or doing inference with 5 to 20 variables results in a water consumption for each inference run of about 500 milliliters or a 16-ounce bottle of water. consumed as part of the cooling associated with that. So if you have millions of users running millions of problems or that each require an inference run, that's a significant amount of water in a really short period of time.
Right. And so these are some of our most precious and valuable commodities. The amount of carbon they were dealing with, the amount of water, and then the energy, the electricity. So it's pretty important to consider that as part of how you now factor your investments in data centers and infrastructure. So let's dig into that. How is the infrastructure that supports AI, massive AI undertakings that we're describing, differ from the past? Why are such things as density for energy use in racks and air cooling need to be re-examined if we're going to move forward into this new era of AI?
Yeah, it's a great question. And part of this challenge and why it comes up is as we think about these new workloads, the question becomes, can our existing infrastructure and existing data centers handle that? And several things that we think are pushing us to consider either new facilities or new co-location locations are things like rack density going up. Global surveys look at rack densities, and the most commonly reported rack density today is about 4 to 6 kilowatts per rack. Yet we know with AI training systems and even inference systems that are doing lots of inferencing, those rack densities may be up in the 20, 30, all the way up to 50 kilowatts per rack. So many existing facilities aren't made to handle that power density at all. The other thing we know is so many facilities continue to be air cooled. So they're taking outside air, cooling it down, and then providing that to the IT equipment to remove the heat from the IT equipment. Well, what we know is when you start getting above 20 kilowatts per rack or so, air cooling is less effective against some of those high heat producing workloads. And you really need to make a shift to direct liquid cooling. And again, what we find is so many data centers that exist today, whether they're privately owned or even in a co-location space, don't have the capability for that liquid cooling that's required. So that's going to be another change. And then I think the third thing that I would mention here is because these workloads that are running both the training and the inference often have accelerators in them as well, what we're seeing is the critical temperature that those accelerators, along with the CPUs, have to be kept below to run most effectively is actually dropping. So at the same time, we have higher densities, higher heat generation, and therefore a need for more effective cooling. The critical temperature of the most critical devices are dropping. So these three elements put together are really what's driving a tremendous amount of data center infrastructure change in the future.
And this is not just going to impact your typical Global 2000 enterprise on-premises data center. This is going to impact co-location providers, service providers, the entire ecosystem of IT infrastructure providers and service providers.
Yes, absolutely. And I will say that many of these providers have already started this transition for their normal non-AI types of workloads as server efficiency is dramatically improved, particularly in terms of performance per watt, as rack densities have grown, partially because one of the ways that co-locations charge their customers is by space used, and another way is power consumption. So if you're trying to do as much work as possible for the same watt of power and you're trying to do it in the smallest footprint possible, you naturally have raising rack densities. So this trend has already started, but AI accelerates that trend dramatically.
It occurs to me, John, that for 30 or more years, there was a vast amount of wind in the sails of IT and its evolution in the form of Moore's Law, and that the ability for the processor to improve its efficiency and capability and scale rapidly over time was often taken for granted in terms of the economics of IT in general. And then in the last, more like 5 or 10 years, we've had advances in virtualization and utilization improvements and improvement in data and reducing dupes and other efficiencies. But it now seems that with all of that efficiency and improved capability, we're almost doing the reverse, that we have higher costs because of more demand for some of the most expensive and precious resources that we have. Do we kiss goodbye any notion of Moore's law, or how long can this continue before we need to find a new plateau or even ability to cut costs rapidly within these newer compute environments?
Yeah, it's a great question. And those of us that are technologists, of course, we love to find technology solutions to challenges. And as we've really pushed on energy efficiency and performance per watt, we have seen predicted in many cases a end of Moore's law, and then we find new ways to develop higher functioning processors with better performance. And so we haven't hit thresholds there that have really stopped us. And increasingly, again, I think that's going to continue to grow performance per watt. And that's really what all of the processor vendors are pushing on, is that performance per watt equation. I think that trajectory is going to continue into the near future, at least. At the same time, though, when we think more broadly, we have been on a focus on energy efficiency, which is literally consume less power per device. But one of the things that we've seen is, as you look at human behavior over the past 2 decades, every time we've been able to save energy in one place, it doesn't mean that overall demand drops. It means that people get another device that they can't live without. We all now have cell phones in our pockets, which 2 decades ago we didn't even know we needed. And now we have tablets and laptop computers and the internet and all of the things that we have come to not be able to live without, to the point that every time we drive these power efficiencies, there are new uses for technology, many of which, by the way, decarbonize other processes. So there's a definite benefit there. But we've always got to weigh that. Is this technology solution the right way to solve the challenge? And what are the societal and environmental impacts of a new technology solution, so that we can make the best decisions?
And in addition to this evolution of technology towards productivity and per watt efficiency, there's also, I think, market factors involved, that if the costs are too high, then the marketplace won't be able to sustain the solution on a cost-benefit analysis basis. And so if you're able to reduce costs as the only way to make solutions viable, that's going to be what the market's demanding and what your competitors are going to force on you. And then the second pillar is the compliance and regulatory factor. In fact, in May of 2024, the European Union Energy Efficiency Directive kicks in. And so maybe you could provide what you see as the motivations, even, not something you can have any choice over, that these are compelling facts of life. There's the economy, the money involved, and the regulatory implications.
Yeah, absolutely. And in fact, one of the things that we're certainly seeing some evidence of out in the market is a tremendous amount of money being spent to develop some AI technologies. And then really a hard question about, what's the return on investment for that initial money spent to build the model and train the model? And can we prove out the return on that investment over the long term? And I think customers, wisely so, are asking those questions. We're also, from an HPE perspective, really making sure the customers think about the ethical consequences and the societal consequences of these AI solutions as well. Because what we don't want is a customer bringing an AI solution to market and having a unintended consequence from a bias that's discovered, or some other aspect, privacy, cybersecurity, that they had not considered when they built the solution. And so, to your point, there's also this increasing interest in regulatory constraints for AI solutions, for all of these reasons that customers are going to have to contend with as well.
So one way or another, you're going to be seeking a fit-for-purpose approach to AI implementations, whether you want to or not. And so I might as well start on that earlier than later. Let's move now towards ways that we can accomplish what we've been describing in terms of keeping the costs down, the energy demand down, making sure that the business benefits outweigh the costs in a total sense. What are some of the ways that HPE and your research organizations and all of the productivity directives that you've been working with on things like general sustainability and transformation, how can they be leveraged and brought to bear on the AI transformation issue?
One of the things that we've discovered in 22 years or so of working with customers, specifically on sustainable technology broadly, is we've discovered 5 levers, and we intentionally call them levers because we believe that all of them apply to every customer, whether they have their workloads in the public cloud, in a hybrid or private cloud, in a bare metal environment, whether it's on premises or colo, or even out on the edge. And yet we know that they can drive efficiencies if customers are considering these. And those 5 are: first, data efficiency, which we've talked about a little bit already. And from the AI context, it's both: how do we make sure that the data sets that we're using are optimized before we run the training? How, when we process a bit of data in a training environment, for example, do we avoid processing it again if we can? And really, how do we make sure that any data that we're going to train for or derive from an inference, that there's actually a use for, that data provides business value? And then it's all the way down to, if we're going to collect data, how do we make sure that we make an intentional decision on the front end about how long we're going to store that data, how we're going to store it, what type of storage? Is it something they need instantaneously and have high availability storage, or can that go all the way down to tape storage if it's more an archival or regulatory requirement to keep that data for a long period of time? So data efficiency is where we suggest we start, because making the right decisions there flow down through all of the other aspects. The second one is software efficiency. And this really, from a broader technology perspective, is how do we write more efficient software applications? How do we reduce the carbon intensity of software applications? All the way through to how do we use software to drive efficiency? So from an AI perspective, this gets into model development. How do we develop more efficient models? How do we design these models or leverage existing models to be as efficient as possible, to need the least amount of compute capability, storage capability, networking capability to operate most efficiently? Then it's even things for the efficiency of that coding. Can it be in a compiled language versus a non-compiled language, so that it takes less power and CPU capability to run that software as well? And HPE brings many of these tools to the market in that environment. And then how do we use software to drive efficiency? One of the things that we're seeing lots of interest in AI are things like predictive maintenance and digital twins, where we can actually use software tools to predict things like maintenance cycles or failures, things like operating behaviors, buying behaviors. We even see these used in terms of the design of data centers. How do we shift workloads for most efficient and lowest carbon operation? So all of those aspects are in software efficiency. And then we move into the hardware stack, and that starts with equipment efficiency. And this really is all about, if you have a piece of technology equipment, have it do the most amount of work, because we know from global industry surveys that oftentimes technology equipment is very underutilized for a variety of reasons. There's redundancy and resiliency built into the solutions. And so there's a variety of reasons it is that way. But as we start moving into AI, we tend to be looking at hardware and software solutions that look for high levels of availability across the equipment infrastructure. So on one hand, by the very nature, AI is designed to run this equipment at higher levels of utilization. And it's large, particularly in terms of training, it's large single workloads that run across a variety of devices as well. But our equipment efficiency is all about high levels of utilization. Then we move to energy efficiency. And this is really, how do you do the most amount of work per input watt of power so that our devices are as high performing as possible. We tend to call that energy effective. Can you do the most amount of work with the same input of energy? And it's really, from an AI perspective, so critical again, because these systems do consume so much power often, that we're able to demonstrate the benefit for that input watt of power, or that volume of water that we're using from a cooling perspective. And finally, resource efficiency. And that's really about how do we run technology solutions so that they need the least amount of resources, like auxiliary cooling or power conversions, or even the human resources that it takes to run these solutions. So from an AI context, again, we've talked about raising power densities and how that shift to direct liquid cooling is going to be so critical. And it turns out that as you move to direct liquid cooling, that's got a much lower power percentage compared to some of our air-cooled infrastructure. You can drop your power consumption dramatically by moving to direct liquid cooling. Same way from a staffing perspective, as you start having analytics that allow you to monitor all of these aspects across your technology solution, which is so common, by the way, in an AI solution, you have it needs less staff to run, and the staff that are running those solutions are much better, much more effective, I should say, and have a higher level of employee satisfaction, because they can see how the infrastructure is doing a lot of the mundane tasks itself, as it's constantly tuning and being made more efficient.
Well, this is a non-trivial undertaking. Obviously, when planning out the efficiencies across your data centers, many years, even decades of planning, implementation, and then operating efficiencies over time, it occurs to me, John, that smaller companies that want to do AI themselves and want to customize their models and their data sets for particular uses, and even proprietary and advantage-based operations, are going to be hitting a bit of a wall when it comes to how to put these things into practice at an efficient and efficiently cost basis. And at the same time, for large hyperscalers that are building out and are very good at building out efficient data centers, they might not have the ability to do the models with the data and at the complex customization required of a small company. So it seems to me that somehow an ecosystem is going to shake out where these efficiencies are going to manifest, but it's not all going to happen at the granular level, company by company, and it can't happen at the cloud provider by cloud provider either. Do you have any sense of how we can create an ecosystem, a variable layered approach to AI as a service that can take advantage of these complex but essential efficiency levers?
Yeah, exactly what you describe is what we see happening as well, that we have some customers that want to make the investments in the high performance compute and in the development and in training of their own AI solutions. And those customers are very few that want to make that type of investment. Other customers want access to that capability, and either have some of that expertise themselves or want to leverage a vendor like HPE's expertise from a data scientist perspective, from a model development perspective, from a data efficiency perspective. So we certainly see a lot more customers that are interested in that. And then there's a level above that, customers that want to take a pre-trained model and just tune it using their own specific data. And we think that segment of the population is even broader there, because so many really valuable uses of AI still require training on task-specific or organization-specific data. And finally, we see just a very large range of customers that want to take advantage of pre-trained, pre-tuned AI solutions that, say, are applicable across their industry or something. And one of the things that HPE has found over the years is, as we've built all portions of that stack and then partnered with companies that perhaps make some very specific use cases, vision learning or something like that, where we're partnering with those camera vendors and things. Having that whole portfolio and having the expertise across them allows us to look both downstream and upstream to perhaps what the customer is looking at and help them make the most efficient decisions. And because we look across the hardware, the software, and that ecosystem of partners as well that we can tap into, it does, in our mind, allow us to leverage that decades worth of experience to help the customer have the most efficient and the most effective solution when they're implementing AI solutions.
All right, John, are there any, you mentioned a use case or two in there. Are there any other use cases or examples that we can look to of how the performance per watt equation has been successfully managed, and that AI modeling, even at a large scale, has started to be done efficiently, or at least able to justify the costs and the investment? Where is this working, and what can we learn from those examples?
Yeah, I'll give you just a couple examples. Obviously, an early adopter of some types of AI systems have been healthcare. And really, it's how do we, in an environment where the very well compensated and very well educated providers are having to make these individual decisions. A great one, for example, is x-rays and looking at x-rays. And it turns out with machine learning, you can actually do a pretty good job of having an ML system look at x-rays doing vision scanning and make a decision, is that bone fractured or not, for example. And if it's unsure, pass that to the radiologist to take a deeper look. And what you get out of that is you can tune the system very, very well. There's a large population of x-ray imagery that create some very clear examples of something is a fracture, something is not a fracture, for example. And there's been lots of studies looking at how do these systems perform against a single radiologist looking at these x-rays as well. And particularly when a radiologist is spending their day going from x-ray to x-ray to x-ray, there is some fatigue associated with that as well. So actually their diagnostic capability gets better when the system could do a first level screen and then pass the more specific cases to the radiologist for a deeper analysis. Or if there's something that's not really clear one way or the other, let the radiologist spend some more time with that. So that's a great one. We're seeing a lot of interest in manufacturing processes as well. How do we look at something using video, usually, and video analytics to look at parts or final assemblies coming off an assembly line and say, does this appear the way it's supposed to from a quality perspective? Are there any additional components, or are there any components missing, for example? So it turns out those use cases actually do a really good job from a power performance perspective and from a return on investment perspective as well.
Go
ahead.
No, continue.
Yeah. So then if you start diving deeper into that, then it's really, even as we move into natural language processing, how do we train tools that can answer some basic customer questions or allow the customer to interact from a voice perspective with a service tool that can provide some low-level diagnostics for a customer, or route them the appropriate way, or in some cases, even give them the right answer. And we see that both in voice speech, but also in type speech. And in fact, you're seeing some of those come out in some very popular software applications that a variety of people around the world use. We're starting to see those AI assistants that predict the next couple words in a sentence, for example, or allow for a higher level of productivity. I think those, again, are still proving their case. In some cases, users see them as a barrier, not as an assistant. But I think the time will come as those start getting more and more accurate, that they're going to be really useful tools.
Well, it certainly seems that given the costs and the impacts on carbon load, on infrastructure, on the demand for skills to support it, that it's incumbent on companies, big and small, to be quite choosy about which AI use cases and problems they seek to solve first. This just can't be a a solution in search of a problem. You need to have a very good problem that will deliver very good business results. Um, how do companies think about this more holistically rather than just one part of the company, perhaps the data science part or the research arm? It seems to me that now AI has forced transformation of the entire organization to be thinking carefully about where it puts its resources and how it uses these new intelligence capabilities to its fullest effect, and picking the right use cases and tasks earlier rather than later.
Yeah, absolutely. And you said it. It's let's not have a solution in search of a problem. Let's find these business challenges or these business opportunities that a company is trying to solve, and then look at what are the right strategic approaches to solve them. What's the return on investment for each of those solutions? What are some of the unintended consequences, like a privacy issue or a bias issue that you want to try to prevent in those? And then how do we learn from others that have implemented those tools and partner with vendors that have a lot of historical competencies in those topics and have helped many customers bring those solutions to market? So it's really finding the best solution for the business challenge and being able to quantify that benefit. One of the things that we did really early on as we were developing our sustainable IT approach is we recognized that so many customers didn't know how to get started. So we offered in a free workbook to customers called 6 Steps for Developing a Sustainable IT Strategy. Well, one of the things that says is so often, and this is germane to these AI conversations as well, that the customer didn't measure the impact of what they had today. So they didn't have a baseline. So they implement a technology solution and then say, that must be much better because we're using technology. But without measuring the baseline, they weren't able to quantify in many cases the financial or environmental or carbon implications of the new solution. So what we've tried to do as we help customers along this journey is help them think about this strategically, get all the appropriate organizations within their company that need to be part of making a decision about these solutions together. So, for example, if you're worried about cybersecurity implications, make sure the cybersecurity team is part of this project team. If you're worried about bias implications, make sure that your legal teams are involved and anyone else that's looking at employee or customer privacy. If you're thinking about solutions that are going to decarbonize or save power, for example, make sure you have your global workplace teams involved that can help quantify that, and your sustainability teams if you're going to talk about carbon mitigation as part of all of this. So it's having the right organizations involved, looking at that can make or help make the decision, is this solution really sustainable, and does this have both a financial return on investment, but an environmental return on investment that makes sense.
And it sure seems that emphasizing AI sustainability should be coming from the very top of the organization, any organization, and in very loud and impressive terms, because AI is a core competency, whether you source it, whether you do it in-house, is going to be an essential business differentiator. And if you're going to do AI successfully, you're going to have to need to do it sustainably. And so AI sustainability seems to me a pillar of getting to an AI outcome that works for the organization. All right, as we move to the end of our discussion, John, it's been very interesting. What are some resources that people can go to? How can they start to consider what they've been doing around sustainability and extending that into AI, or examining what they're doing with AI and making sure that it conforms to some major concepts around sustainability and these objectives of efficiency?
Yeah, I think the first one is one that we've already talked a little bit about, which is make sure you have a sustainable IT strategy that's part of your overarching technology strategy. And now that it includes AI, because some of the nuances we've talked about really get accelerated with AI workloads. And part of that strategy is getting those stakeholders together so that we have folks that can help look for the blind spots and help quantify the implications and the opportunities of that. And then really look across the entire environment from public cloud to edge, hybrid cloud and private in the middle, and really look across those 5 levers that I talked about, particularly emphasizing data efficiency and software efficiency from an AI perspective. And then look all the way across the life cycle from the design of those products to that retirement at the end of life. Because when we think about IT life cycles, we really need to consider all the aspects in the middle. So that drives things like, how do you procure the most efficient hardware in the first place and the most efficient solutions? How do you think about tech refresh cycles, and why are tech refresh cycles different for compute than storage than networking? And with AI, how do all those pieces interconnect to think about tech refresh cycles? And from an HPE perspective, then, one of the things that we've done is written a whole series of resources for customers. We mentioned the 6-step for developing a sustainable IT strategy workbook, but we also have white papers on software efficiency and data efficiency, and energy efficiency and equipment efficiency and resource efficiency as well. And we make those freely available on HPE's website. And so really, I think it's use those resources that exist, partner with vendors that have core capability and core expertise across all of these areas of efficiency, and really spend a fair amount of time in the development process trying to ensure that return on investment, both financially and from a sustainability perspective, really are positive as we're implementing these solutions.
Well, great. I'm afraid we'll have to leave it there. We've been exploring how AI deployments will demand vast resources, energy, water, skills, an upgraded or wholly new data center and electrical grid infrastructures. And we've learned that not only by calculating the true and total expected costs in the fullest sense can businesses predict the proper fit for purpose use and deployments of AI, but doing it in the most efficient manner might be the only way to go about successful AI deployments. And so please join me in thanking our guest. We've been here with John Fry, Director and Chief Technologist of Sustainable Transformation at Hewlett-Packard Enterprise. Thank you so much, John.
Yeah, thank you for letting me come on and share this expertise.
You bet. And thanks as well to our audience for joining us for this sponsored Briefings Direct discussion on the best path to sustainable AI. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of HPE-sponsored discussions. Thanks again for listening. Please pass this along to your IT community and do come back next time.